Okay, in this video I'm going to solve a few more integrals using substitution rule, and as you can see in the definition and in the first problem, these are definite integrals. So because they are definite integrals, let's remember the fundamental theorem of calculus, which says if you have integral from a to b of f of x dx, you're gonna get the antiderivative of f of x evaluated from a to b, which is f of b minus f of a, where f prime of x is f of x. So let's see. The very first problem is integral from 0 to pi over 8 cosine of 2x dx, and this one, well, we have a formula for it, but let's do substitution. So obviously the inner function is 2x, so we'll say u equals 2x, or 2x equals u. So du equals 2 dx, or dx equals du over 2. So now I am going to integrate, and then I'm going to put cosine of u times du over 2. Now as you notice, my new variable, it's u, right? So it's not x anymore. Here we had x. So x was going from 0 to pi over 8. Now u doesn't go from 0 to pi over 8 anymore. So how do I figure out u? Well, we're just going to replace in the substitution. So we say if x equals 0, from where? From this. Then u equals 2 times 0, which is 0. So the bottom limit is 0. If x equals pi over 8, then if x equals pi over 8, u equals 2 times pi over 8, which is pi over 4. So the integration now is from 0 to pi over 4. Again, I'm just going to color code it. So you see, the ones with blue are the x ones, and the limits were from 0 to pi over 8. The one in yellow, it's a u, and u goes now from 0 to pi over 4. So here, I'm just going to continue the problem here. That's why I mark it with a star, so that it's easy to read. This half comes in front. Integral from 0 to pi over 4, cosine of u du. Well, integral from cosine of u du, it's sine of u, because sine of u prime is cosine, evaluated from 0 to pi over 4. So we get 1 over 2 sine of pi over 4, we start with the top one, minus sine of 0, the bottom one. And minus is from the formula. So we get 1/2, sine of pi over 4 is square root of 2 over 2, sine of 0 is 0, so we get square root of 2 over 4, and that's the final answer. Another way you could have solved this problem, having the limits, well, I'm going to do that on the next problem. I'm going to show you how to calculate the limits in a different way. So let's look at the problem from the bottom, from the problem that we see. Integral from 0 to pi over 4 sine of theta over cosine cubed theta d theta. So I am going to set u equals cosine theta. So du equals negative sine theta d theta. So basically d theta is negative du over sine theta. Now again, the integration, it's in u now, right? So it's not from 0 to pi over 4 anymore. So you know what? I'm just not going to use the limits. I'm just going to calculate it as if it was a integral, right? So I just put no limits here. So we have sine of theta. I'm just going to copy it. Sine of theta. Because the substitution is for cosine. Over u to the third times d theta, which is here, times negative du over sine theta. And you see, if you are worried that you get the theta, you don't. So we just cancel it. So we get negative integral du over u to the third, or integral, negative integral u to negative 3 du. So here we know how to use it. It's negative u to negative 3 plus 1 over negative 3 plus 1, which is negative u to negative 2 over negative 2. So many negatives. These two are making 1 over 2 u to the second, right? Okay, but our original problem was in theta. So I'm going to replace 2 times u with cosine theta. So it's going to be cosine squared of theta. And now, actually, my problem is back in theta, right? It's in theta. Theta was evaluated from 0 to pi over 4. So I can just put from 0 to pi over 4 without changing the limits of integration, because I change it back to the original variable. So it's going to be 1 over 2 cosine squared of pi over 4 minus 1 over 2 cosine squared of 0. So let's do the math. 1 over 2 cosine of pi over 4 is square root of 2 over 2. Squared is 2 over 4. Minus 1 over cosine of 0, it's 1. So 1 over 2 times 2 divided by 4, it's 1, minus a half. It gives us a half, and we solve it. Now, if you are curious, you can just change the limits of integration in u and see if you get the same thing. Okay, let's see another problem. Integral from 0 to 2 of x cubed square root of 16 minus x to the 4th dx. By now, you might wonder, how do I get those substitutions right away? You know, well, first of all, it's experience, and second of all, you should try to find the connection between the functions that you have. Just by looking at this one, I have an idea that if I differentiate it, I get x cubed with some constant, so I get this one. So obviously, the 16 minus x to the 4th would be my choice for u. So du would be negative 4x to the 3rd dx. So dx is negative du over 4x cubed. Right, so basically integral x cubed square root of u times negative du over 4x cubed. So you see how x cubed cancels with x cubed? That means we are on the right path. Now the limits of integration, I'm not going to put anything because I'm going to replace at the very end. So negative integral of u to a half du. Well, we are using the most popular formula, x to the n dx. Integral of x to the n dx is x to n plus 1 over n plus 1 plus c, right? But I'm not writing the c because this one is definite integral, so the c cancels. So it's u to 1/2 plus 1, which is 3 over 2, over 3 over 2, which equals negative 2 over 3, u square root of u, and I still am not in x yet, so negative 2 over 3, 16 minus x to the 4th, square root of 16 minus x to the 4th, evaluated from 0 to 2. So now I used 0 to 2 just because I have the same variable as the original problem. So we get negative 2 over 3. Now we replace everywhere we see x, we put 2. So it's 16 minus 2 to the 4th, square root of 16 minus 2 to the 4th, minus from the formula, and now I copy everything again, so negative 2 over 3, and instead of x we put 0. Okay, so 2 to the 4th is 16, so this whole quantity here is going to be 0. Negative, it's going to give me 2 over 3, here, sorry, it was a minus, times 16 times square root of 16. So 2 over 3 times 16 times 4, so 16 times 4 is 64, times 2, 128 over 3, and there you go. Okay, and we have just 3 more. So let's see. This problem, okay, interesting. Well, if somebody says, well, let's set u equals 9x squared plus 6x plus 1, then we would have du equals 18x plus 6 dx. So dx would be du over 18x plus 6. Now when you replace back into the equation, it's going to be 4 over u times du over 18x plus 6. Well, you see, there is a problem. What's the problem? That's right, x and u in the same, they don't cancel, they canceled everywhere else. So what does that mean? Our choice of setting u equals 9x squared plus 6x plus 1 was not successful. So I'm going to erase it and we'll have to figure out another way. Well, how about we factor the denominator? Well, if you factor the denominator, you notice that it's 3x plus 1 squared dx. How about we set 3x plus 1 equal to u? du would be 3 dx. So dx will be du over 3. So basically our integral is going to be integral. Again, I'm changing the variable, so I'm not going to use 1, 2, 2. Well, actually, how about we set if from here? If x equals 1, u equals 4. If x equals 2, u equals 7. From where I got those? From the fact that x is 1 or 2, and then we have u equals 3x plus 1. So basically the integral now is from 4 to 7, and is going to be 4 over u squared times du over 3. So do you see how now everything is in u, even the limits of integration are different? So we can forget about the x entirely. So we have 4 over 3 integral from 4 to 7 of u to negative 2 du. So 4 over 3 u to negative 2 plus 1, which is negative 1 over negative 1 from 4 to 7. I simplify a little bit, so it's 4 over 3 times 1 over u from 4 to 7. So it's negative 4 over 3, 1 over 7 minus 1 over 4. Let's just do some math. Same denominator, so negative 4 over 3, 4 minus 7 over 28, negative 4 over 3 times negative 3 over 28. These two cancel, so we get negative 1, not negative, sorry, positive, because I have this negative and I have this negative, so 1, 7. Okay, now well, this one is a little bit different. So let's do u equals x minus 2. So du equals dx. Okay, so now you see what's different here is this is x by itself. So if you leave it just by itself, you're going to get x over u to the third du. So we still have x and u inside. So what I'm going to do from here, I'm going to solve for x, and it's going to be u plus 2. So if we, at the top, instead of x, I put u plus 2, then there you go, we have everything in u. So I can separate it into u over u to the third du, plus integral of 2 over u to the third du. So you get 1 over u to the third squared, sorry, because you cancel du, plus integral of 2 over u to the third du. So please finish this on your own. And the very last one, let's see, how do we solve this one? Well, there are a few methods. Method 1, use formula from trig, cosine squared of x, formula from trig. It's reducing the power, so try to find that. Method 2, let's do the substitution. So I'm going to do this, integral from negative pi to pi cosine of x times cosine of x. Can I do that? Dx. Well, actually, the substitution is not going to get us anywhere. So I'm just going, there are no two methods. So I'm going to use the formula from trig. So basically, cosine of 2x equals 2 cosine squared of x minus 1. And if we solve this, we get cosine squared of x. It's cosine of 2x plus 1 over 2. So this one, I can actually write 2 integral from 0 to pi cosine of 2x plus 1 over 2. And you might wonder, why did I write from 0 to pi? Well, we learned in 5.4 that cosine, it's an even function, cosine squared it's even, so I can write 2 times. So this 2 cancels with this 2, and we end up with integral from 0 to pi cosine of 2x dx plus integral from 0 to pi of dx. Well, this one was done at the beginning, so we calculated that integral, and the second one is just x from 0 to pi. So the first one you just calculated or replace it from the beginning, so we get plus pi. Well, just be careful, at the beginning we calculated cosine of 2x integrated from 0 to pi over 8. So what you have to do is you have a different limit of integration. So be very careful what you use for your limits of integration. I hope this helps.